the vision of allowing first responders across Europe to seamlessly interoperate, overcoming current legal, operational, and technological barriers. You see in the picture the typical layer step where that we use in order to explain the framework. Our idea is, once again, you cannot have technology without procedures and legal framework. You cannot have a legal framework and procedures for interoperability without the technology, as the Norway-Sweden case clearly shows. Being a research project, the challenge we try to address all these aspects. The mission-oriented model, we know that is a hot topic for SP3, and we leverage on the expertise and the experience between Norway and Sweden, and we hope to elevate this example, best practice, to a European level, where we have to deal with different procedures and legal frameworks across European countries. Okay? And we want to propose a framework that can be reused and adapted when the other countries will have the money or we get the financing for implementing, as you have done, the real interoperability. The cross-national communication infrastructure, here comes the technical and technological part that is related to the development of ISI. ISI is a central standard, but in the project we interpreted the meaning of ISI in larger terms, meaning not only to interconnect tetra networks, but also to interconnect tetrapole networks, that is the other reference standards for public safety across Europe. Okay. Then multi-standard terminals, and here for sure multi-standard terminals is something new, and what we in the idea of the DAO and of this proposal, the idea of multi-standard networks was to address a technological challenge related to the fact that roaming, when you have different waveforms across tetra and tetrapole, is not possible without a step, a capability step. A technological possibility could be software-defined radio, but here in the project, for sure, what we want to show is the possibility to implement and support interoperability across tetra and tetrapole, leveraging on the capabilities of the terminal. But it won't be a real product; it will be a prototype, a concept that could lead the way for implementation, for example, based on software-defined radio, when the waveforms for tetrapole and tetra will be available, or whether we have a business case for implementing this kind of terminals. We all know, and I think Laura agrees, we have some concern about the numbers there, of how many terminals really will be needed by the market, will be invested by the market, whether they can be enough to cover the cost of development and to gain something from that. Then interoperability enabling tools. This is the matter of SP6, mainly SP6, where we have the tools that on one side shall support the implementation on interoperability, giving the numbers, how many base stations, how I should dimension the ISI interconnections, and let me say, give a framework for business sustainability of the interoperability. Of course, we have a moral reason, let me say, to implement interoperability across Europe in order to have to reinforce the links across our nations across Europe. At the same time, we all know that interoperability can add value because through interoperability, the sum is not the value that we deliver is more than the sum of the people that we have in each country, because we are going to share resources. We are better in dealing with, let me say, threats that are cross-country, okay? And they can be, okay, natural disasters, they can be day-to-day accidents, and so on, as the example from Norway. So, interoperability enabling tools wants to give a clear example of how interoperability can add value. At the same time, we see in this part also applications that are nice to have. They are not needed for interoperability, but are nice to have, are enablers for interoperability, like location-dependent addressing, functional addressing, but we'll see later on.